In this video, we'll learn about some properties of logarithms. In a previous video, we went over some basic log properties, such as log with any base of 1 is always 0, and how logarithms and exponentiation are inverse operations. In this video, we'll go over 3 additional properties involving logarithms. These properties are counterparts to exponential properties, so we'll first mention the exponent property, then we'll see what the corresponding log property is, and then we'll look at an example. Our first exponent property is a to the power of m times a to the power of n. We know we can combine this expression together to get a to the power of m plus n. So if we multiply a to some power times a to another power, then in the end, we'll have a to the power of the sum of the two powers. Now, the corresponding log property says this. If we have log with base a of x times y, then this can be rewritten as log with base a of the first factor x plus log with base a of the second factor y. This logarithm property is the counterpart to this exponent property because if we label a to the power of m as x and a to the power of n as y, when we ask for the logarithm with base a of x times y, we're essentially asking a to what power gives me x times y. Well, according to our exponent property, x times y is a to the power of m plus n. It's the exponent of x plus the exponent of y, which is what we see on the right-hand side here. Log with base a of x is the exponent that we raise a to get x. And if a to the m is equal to x, then our logarithm here is going to be m. And log with base a of y is the exponent that we raise a to get y. And if a to the power of n is equal to y, then this logarithm is going to be n. So we see here this right-hand side is m plus n, which is what we see in this exponent property. When we multiply x and y together, the power that we raise a to get this product is m plus n. Let's take a look at an example to see this property in action. If we have log with base 3 of 9 times 3, this can be split up into log with base 3 of 9 plus log with base 3 of 3. Let's calculate both sides to confirm that this is true. On the left-hand side here, 9 times 3 is 27. So if we take the logarithm with base 3 of 27, we're asking ourselves, 3 to what power gives us 27? And the answer there would be 3. 3 to the third power gives us 27. Now let's calculate the logarithms on the right. First, we have logarithm with base 3 of 9. So we want to ask ourselves, 3 to what power gives us 9? Well, 3 squared gives us 9, so this logarithm is 2. And then log with base 3 of 3 is asking us 3 to what power gives us 3? Well, 3 to the first power is 3, so the answer to this logarithm is 1. And we see here on the right-hand side we have 2 plus 1, and it does equal 3. So this is a confirmation for us that this log property is true. Let's take a look at a second property. The exponent property that we'll be looking at is a to the power of m divided by a to the power of n is equal to a to the power of m minus n. So when we divide two exponential expressions with base a, we can combine things together to get a to the power of the exponent of the numerator minus the exponent of the denominator. So now let's see what the corresponding log property is. If we have log with base a of x divided by y, this can be rewritten as log with base a of the numerator minus log with base a of the denominator. Again, we can see how this log property is related to this exponent property if we label the a to the power of m here as x and a to the power of n as y. So when we ask log with base a of x divided by y, we're asking a to what power gives us x divided by y? Well, x divided by y here is a to the power of m minus n, the exponent of the numerator minus the exponent of the denominator. And that's what we see on the right-hand side of our log property. Log with base a of x is the power that we raise a to get x. And with how we labeled things, this would be m. And log with base a of y is the power that we raise a to get y. And with how we labeled things, this would be n. And so what we have on this right-hand side here is m minus n. And that's what we see in this exponent property. We have a to the power of m minus n. Let's now take a look at an example. Let's say we have log with base 2 of 32 divided by 4. And according to our log property, this can be split up as log with base 2 of 32 minus log with base 2 of 4. Again, we'll try to compute both sides of this equation to see that this log property is true. On the left-hand side here, we have log with base 2 of 32 divided by 4. Let's start by dividing 32 by 4. We get 8. So on the left-hand side here, we have log with base 2 of 8, which is asking 2 to what power gives us 8? Well, 2 to the third power gives us 8, so the answer to this logarithm is 3. Now let's compute things on the right-hand side. Here, log with base 2 of 32 is asking 2 to what power gives us 32? Well, 2 to the fifth power gives us 32, so the answer to this logarithm is 5. And here we have log with base 2 of 4. It's asking us 2 to what power gives us 4. Since 2 squared is equal to 4, the answer to this logarithm is 2. And we see here on the right-hand side, we have 5 minus 2, and that is indeed equal to 3. Let's look at one last property. The exponent property that we're interested in this time is if we have a to the power of m, and we take this whole expression and we raise it to the power of n, this can be simplified to a to the power of m times n. The corresponding log property says this. If we have log with base a of x to the power of n, then this can be rewritten as n times log with base a of x. We can see how this log property is related to this exponent property if we label a to the power of m as x. So on the left here, we have x to the power of n. And when we ask for the logarithm with base a of x to the power of n, we're essentially asking a to what power gives us x to the power of n. And we see here in the exponent property that x to the power of n can be rewritten as a to the power of m times n. So the power that we raise a to get x to the power of n is the product of the original power of x times the exponent that we raised x to. And that's what we see on the right-hand side of our log property. N is the power that we raised x to, and it's multiplied to log with base a of x. And that's the power we raised a to get x. And with how we labeled things, this is our m. So on this right-hand side of our log property, we have n times m, which is the exponent that we raise a to get x to the power of n. So basically what this log property tells us is that if we have an exponential expression inside a logarithm, we can take the exponent and move it outside of the logarithm as a multiple. Let's take a look at an example. Let's do log with base 2 of 4 to the third power. According to our log property, the exponent 3 here can be brought outside of the logarithm as a multiple. So we can think about this as 3 times log with base 2 of 4. Again, let's compute both sides to confirm that our log property is true. On the left-hand side, we have log with base 2 of 4 to the third power. 4 to the third power is 64, so we're asking 2 to what power gives us 64? Well, 2 to the sixth power is 64, so log with base 2 of 64 is 6. Now let's look at the right-hand side. The right-hand side, we have 3 times the log with base 2 of 4. So we're asking ourselves, 2 to what power gives us 4? Well, 2 squared is equal to 4, so the answer to this logarithm is 2. So we see here on the right-hand side we have 3 times 2, and that does equal 6. So in this video we learned 3 new log properties. These properties allow us to split logarithms apart or combine logarithms together. Being able to combine logarithms together will be important in solving logarithmic equations, and being able to split logarithms can help make things simpler in calculus.